Welcome to qnawire.
In this question, we are asked to find all pair of integer keys a and b such that the encryption function ap plus b mod 26, which we will call f, is the same as its corresponding decryption function. So decryption function will revert this encrypted message back to its original form. So let's do this. First, we figure out the description function to decode this. We want to, since it result from the first one is this, right? So we minus b to get rid of b, and then we multiply it by a inverse to get rid of a. So it's gonna go back to p. That's how we arrive at this decryption function. And now we want it to look the same, to be the same, both sides. So what we can do is we compare them directly like this. So this is f, this is g, and for this to be true for any message p, it means that each term with p or without p has to be equal. So the term with p will give us that a equals a inverse, and the term without p will give us that plus b equals minus a inverse times b. So these information will be the clues we use for solving this problem. Firstly, a equals minus a. In mod 26, there are only two options. Either is just a is 1 or a is minus 1, which in this case it translates to 25 in mod 26. Why? Because minus 1 square is 1 as well. And now let's go further. So we know that there are only these two cases. We look at them one by one. The first case, if a is 1, the second relation will give us that, okay, then b is equal to minus b, and so 2b is 0 mod 26, sorry, and that has two cases as well. So b can either be 0 itself or half of 26, which is 13. And so the first case we have two pairs, 1 0 and 1 13. For the second case, if a is minus 1, then the second relation will give us that b equals to b, which is like true for any b, right? That means in this case, any b will work with this a. So the pair would be 25b, and b is in Z mod 26. It means we have 26 pair here. So b can be anything from 1 to 3, like 0, 1, 2, 3 to 25. It will not make a difference. And so these, like all of these combined, are all the key that can work for our question. That's how you do it. Let's write this down. So it's 1 0, 1 13, and 25 with any b. That is the answer. Thank you.